Welcome friends. In this video, we are going to learn geometrical meaning of determinant. Some important result which we will use to understand the geometrical meaning of determinant. The first result, norm of 1. Norm of V1 is equal to A1, A2, A3. So norm of vector V1 is equal to square root of A1 square plus A2 square plus A3 square. Dot product between two vectors v1 and v2 is equal to a1 a2 a3 dot b1 b2 b3 is equal to a1 b1 plus a2 b2 plus a3 b3. If angle between two vectors v1 and v2 is theta, then the dot product between v1 and v2 is equal to norm of v1 into norm of v2 into cos theta. Using this result, we can find the value of cos theta is equal to v1 dot v2 divided by norm of v1 into norm of v2. Cross product v1 cross v2 a1 a2 a3 cross product b1 b2 b3 equal to a2 b3 minus a3 b2 comma a3 b1 minus a1 b3 comma a1 b2 minus a2 b1. If angle between two vectors v1 and v2 is theta, then this cross product v1 cross v2 is equal to norm of v1 into norm of v2 into sin theta into n cap. N cap is a unit vector perpendicular to the plane made by v1 and v2. Now we begin with the true cos 2 determinant. Suppose A is equal to 2 cross 2 matrix A, B, C, D. Then its determinant value is AD minus BC. Now consider the rows of matrix A as a vector. So first row vector is V1 equal to AB and the second row vector is CD. Now plot these two vectors in the two-dimensional plane. So we have V1 and V2. Now consider the parallelogram made by V1 and V2. That means parallelogram which sides are parallel to V1 and V2. Now we'll try to calculate the area of parallelogram made by V1 and V2. Its value is nothing but the modulus of V1 cross V2. So modulus of V1 cross V2 is V1 norm of V1 into norm of V2 into sin theta, and n cap is a unit vector, so its value is 1. Now sin theta is equal to square root 1 minus cos square theta. So we have result cos theta is equal to v1 dot v2 divided by norm of v1 into norm of v2. Substitute in this equation. Then just take the LCM. Then we have v1 dot norm of v1 into norm of v2 square root norm of v1 v2 whole square minus v1 dot v2 whole square divided by norm of v1 norm of v2 whole square. So this norm of v1 v2 is cancelled with the square root of 1 upon v1 norm of v2 whole square. So these two terms are cancelled. Then we have square root of norm of v1 norm of v2 whole square minus v1 dot v2 whole square. So norm of v1 is equal to square root a square plus b square. Norm of v2 is equal to square root c square plus d square whole square minus v1 is a comma b and v2 is c comma d. So it's a dot product here. So square roots. So we have a square plus b square into c square plus d square minus the dot product is ac plus bd whole square. By opening these two bracket, a square c square plus a square d square plus b square c square plus b square d square minus square of ac plus bd whole square is equal to a square c square plus b square d square plus 2abcd. So a square c square cancel with the minus a square c square and b square d square cancel with minus b square d square. So we have square root of a square into d square plus b square c square minus 2abcd which is a square of AD minus BC. So therefore, square root of AD minus BC whole square, which is modulus of AD minus BC. But it is nothing but the value of determinant modulus of determinant of A. So area of parallelogram made by the vectors V1 and V2 is equal to determinant of A. So therefore the value of determinant of a 2 cross 2 matrices is the area of parallelogram made by the row vectors of matrix A. Thank you. Now 3 cross 3 determinant. Matrix A is of 3 cross 3 determinant with entries A1, A2, A3, second row B1, B2, B3, and the third row C1, C2, C3. So determinant of A is A1 into minor of A1, B1, B2, B3, C2, C3 minus A2 into minor of A2, B1, B3, C1, C3 plus A3 into minor of A3, B1, B2, C1, C2 equal to A1 into B2, C3 minus B3, C2 minus A2 into B1, C3 minus B3, C1 plus A3 into B1, C2 minus B2, C1. So you can rewrite this term in the form of dot product. So the dot product of A1, A2, A3 dot B2, C3 minus B3, C2, B1, C3 minus B3, C1 and the third component B1, C2 minus B2, C1. So this is nothing but the dot product between V1 dot V2 cross V3, where V1 is the first row vectors of matrix A, A1, A2, A3. V2 is the second row vectors of matrix A, B1, B2, B3. And V3 is the third row vectors of matrix A, C1, C2, C3. Now consider these three vectors and plot this three vector in the three-dimensional space. Then we have V1, V2, V3. Now generate the parallelopipe made by the vector V1, V2, V3. Now calculate the volume of parallelopipe made by the vectors V1, V2, V3 is equal to the area of base plane made by V2 and V3 into the height of perpendicular drawn from V1 onto the base plane made by V2 and V3. Suppose the area of base plane is A and the perpendicular height is H, then A into H is made by the vectors V2 and V3. Therefore, its value is norm of V2 cross V3 and H is the height drawn from V1 onto the plane V2 and V3. So if angle between V1 and the perpendicular is theta, then its value is norm of V1 into cos theta. But this is the expression of V2 cross V3 dot product V1, or you can rewrite V1 dot V2 cross V3, which is nothing but the determinant of A. So volume of parallelopipe made by this vector V1, V2, V3 is nothing but the determinant of A, and V1, V2, V3 are the row vectors of matrix A. Therefore, the value of determinant of 3 cross 3 matrix is the volume of parallelopipe made by the row vectors of matrix A. Thank you friends. Thanks for watching. For more videos, like, subscribe and press the bell icon of Next Gen Maths.